Question 1. List 5 rational numbers between. First is -1 and 0, second -2 and -1, and so on. First, -1 and 0. So first of all, we'll have to represent this integer, or you can also call them rational numbers, because you've studied in this chapter that rational numbers are those numbers which are represented in terms of ratio, because rational came from the word ratio, where numerator is the upper part, this is your numerator, and this is your denominator. And what differentiates rational number from simple fractions is that in fractions we cannot take negative numbers, or you can call as integers, whereas rational numbers are those fractions which include integers. So this is the only difference between fraction and a rational number. So first of all, we will represent these rational numbers. Now we know why we are calling them as rational numbers, that is -1 and 0. If nothing is written in denominator, we can assume it to be 1. So -1 over 1 will give you -1, and 0 over 1 will give you 0 itself. Therefore, these are rational numbers as well. Now representing these rational numbers with denominator 6. Now here is the tricky part. Why we are taking denominator as 6? Because we are asked to find 5 rational numbers. So had the question asked for list 8 rational numbers, we would have taken denominator as 9. So you have to just increase one digit. This is how we select denominator number. So -1 can be written as -6 over 6, because when you cancel it out, it gives you back -1. And 0 can be written as 0 over 6, because we are taking denominator as 6. So 0 over 6 gives you 0. Now it becomes easy to find 5 rational numbers. Now -1 is written as -6 over 6 and 0 as 0 over 6. Now if you remember the number line, negative is towards left of 0 and positive is towards right of 0 on the number line. Here we are only dealing between -1 and 0, because here we have -1 and 0. So if we magnify it, this is something like this, -1 and 0 like this. Now we are dividing these two rational numbers in 6 parts. So you can see 1, 2, 3, 4, 5, 6, and these intervals are what we have to find. So one will be -5 over 6, because -5 is greater than -6, and we are coming towards 0 on the number line, and -6 over 6 is this bigger bar, which we have also represented with -1, because -1 equals -6 over 6. Now this will be your -5 over 6, as you can see, and -4 over 6 will be your this one, and then again -3 over 6, -2 over 6, -1 over 6, and 0 is your 0 over 6. So these rational numbers highlighted within this rectangular red box is your answer. That is your 5 rational numbers. So the only thing to remember here is that you have to consider denominator 1 bigger than the number of asked rational numbers. So therefore 5 rational numbers between -1 and 0 are these. You can also take as bigger number, and then you will get many rational numbers, but since we were asked to find only 5 rational numbers, we will consider denominator as 6. So that is your first part. Second, -2 and -1. Again, since we have to find 5 rational numbers, we will take denominator as 6. And these are rational numbers as well. Integers are rational numbers, because if in a number there is no denominator written, then we can assume it to be 1. So -2 over 1 and -1 over 1, hence it follows the condition of rational numbers. That is, they must have numerator and denominator, and the numbers would be integers. So -2 can be written as -12 over 6, because we have to represent it in terms of 6. Therefore we have to take numerator such as, if we simplify that fraction, we get -2. Therefore when you solve it, you get -2. Another trick or a method to find this numerator part is, you simply multiply 6 with -2, gives you -12. Again here, 6 into -1 give you -6. So this is how you can get your numerator part. Again, back to -1. So now we have our two extreme rational numbers, therefore -12 over 6 and -6 over 6. Now the question may arise that why we haven't written -6 over 6 towards left hand side and -12 over 6 towards right hand side, because it doesn't follow the number line system. A number line system, left side means smaller number, and since minus 12 is small as compared to minus 6, therefore it is written on left hand side. So now we can get 5 rational numbers between these two rational numbers. Minus 12 will be somewhere here, and we have minus 11, minus 10, minus 9. However, we are not talking about this thing. This is just to tell you that how these numbers are reduced in numerator part, whereas we are only talking in between minus 2 and minus 1, because we are asked to find between minus 2 and minus 1. So if you magnify this part, this portion, so the same has been done here as we did in previous part. This is a minus 2, this is minus 1, and we have divided it into 6 equal parts. So 1, 2, 3, 4, 5, 6. So this will be your minus 11 over 6, minus 10 over 6, and so on. And this is your minus 1 or minus 6 over 6. And this is your minus 2 because it is minus 12 over 6. Therefore, these are the required 5 rational numbers. Again, you have to remember the important things, that is how to reduce denominator. This is 1 greater than the number of rational numbers asked, and smaller number towards left hand side and greater number towards right hand side, because you have to follow the number line system. And then how you can get this numerator part? By simply multiplying the selected denominator with the question itself. 6 into minus 2 is minus 12, and 6 into minus 1 is minus 6. So if you remember these things, every question will be easy to solve. So this is your second part. Third part, minus 4 over 5 and minus 2 over 3. Now here this question is a bit different. Here we are already given with the denominators. We cannot assume the denominator to be anything. So representing these rational numbers with the same denominators as they are, that is minus 4 over 5 and minus 2 over 3. Now we have to follow some steps. First step, we will check if denominators are same or not. Well, they are not. Here we have 5 and here we have 3. So now we have to straight away move to step number 2. Now taking LCM of these denominators. This is very easy. You have learned how to calculate LCM, that is lowest common multiple or the least common multiple of 5 and 3 will be 15. Now if the denominators were same, then it was very easy to find those numbers by just comparing the numerator. Well, that kind of a question will not be asked to you. After that, you have to convert the given fractions into equivalent fractions. That is 5 3s are 15, so 4 3s are 12. Now again here 3 5s are 15 and 5 2s are 10. Obviously signs will also come. Now if you compare minus 12 and 10, only minus 11 comes, but we have to find 5 rational numbers. Therefore we cannot consider denominator as 15. Now we move to step number 3. That is, we write multiples of 15. That is 15. This is eliminated. We cannot take it. Now 15 is a 30. Now we will consider 30. So 5 hows are 30. 5 6 are 30. So 6 4s are 24. Obviously negative sign will also come. Again for this rational number or this fraction. Now 3 how much are 30? 3 10s are 30. So 10 into minus 2 is minus 20. Well, if you again observe, we cannot deduce 5 rational numbers. We can only deduce minus 23 over 30, minus 22 over 30, minus 21 over 30. That is only 3 rational numbers we can deduce, but we are asked to find 5. So therefore, this case cannot be taken as well. Now, third multiple. 15 ones are 15, 15 to the 30, 15 3s are 45. Now we will consider 45. Now again, repeating the same process. 5 how much are 45? Well, 5 9s are 45. So 9 4s are 36. Again, negative sign consideration. Now for this rational number, 3 15s are 45, 15 2s are 30. Again, negative. Now when we try to find, we get exactly 5 rational number, and that's what the question is asking for. So minus 35 over 45. Again, this is left hand side on the number line. That is minus 36 is smaller as compared to minus 35. Then minus 34 over 45. This, and this. So therefore 5 rational numbers between minus 4 over 5 and minus 2 over 3 would be these. Now again, this can also be written as your solution, but as we have learned in previous chapters, that it is always better to write fractions in its lowest form. So this simply means that we can reduce it. So 9 5s are 45, and minus 7 5s are minus 35. So therefore, we are writing minus 35 over 45 as minus 7 over 9. Well, this cannot be reduced in simplest terms. So therefore, we are writing the same, minus 34 over 45. Now here again, reducing apportionity. So minus 11 into 3 is minus 33 and 15 3s are 45. Therefore, we are writing minus 11 over 15. Again, not reducible, writing minus 32 over 45. Again, this is also not reducible. So the required solution for this part 3 will be this. However, you can also write this, but it is always recommended to write the fractions or rational numbers in its least form. So that is your third. Fourth part, minus 1 over 2 and 2 over 3. Now again, since the denominators are different, we have to follow steps. So first of all, we are representing rational numbers with the same denominators, that is minus 1 over 2 and 2 over 3. Now step 1, check if denominator is same or not. Well, they are not. Therefore, we will take LCM. It is 6. We'll try with 6. So first of all, changing them to equivalent fractions with denominator as 6. So first of all, you can write divided by 6 as it is. Now 2 3s are 6. So 3 into minus 1 will be minus 3. So if it is written before fraction, it means you can take minus at any position, that is numerator or denominator. But since you have learnt so far with the numerator, we will go with numerator, that is minus 1 over 2. You can consider this fraction as minus 1 over 2. So now we know how we deduced minus 3 over 6. Similarly for this fraction, that is 2 over 3. Now 3 2s are 6, so 2 2s are 4, so 4 over 6. As you can see, minus 3 is smaller as compared to 4 and there is 0 in between them. So you can consider this as a number line. Here it is 0 and minus 3 lies somewhere here and 4 is here. So clearly we are able to deduce 5 rational numbers. Even we are getting 6 rational numbers, 1 2 3 4 5 6. But we have to consider only 5. You can consider any of them. The only thing is that they must be 5 because we are asked to find 5 rational numbers. So minus 3 over 6 will be somewhere here. Then you have minus 2 over 6, minus 1 over 6, 0 or 0 over 6. It represents the same thing. Now 1 over 6, 2 over 6, 3 over 6 and 4 over 6 is obviously 2 over 3. We have deduced rational numbers. We have to write them in simplest term. So 2 over 6 is reducible. Minus 1 into 2 gives you minus 2 and 3 2s are 6. Not reducible. 0 over 6 is 0. Whenever in numerator there is 0 and denominator is having any integer except 0, the answer will be 0. Not reducible. Again reducible. This can also be reducible, but we are not taking it. Therefore, we are not reducing it here. We are taking only these 5 because we are asked to find 5. So therefore, 5 rational numbers between this minus 1 over 2 and 2 over 3 would be minus 1 over 3, minus 1 over 6. 0 over 6 is 0. Therefore, we have written 0 and 1 over 6 and 1 over 3. We have eliminated this thing. That gives you 5 rational numbers. So this is how you solve such type of questions. So we need not to go to step number 3 because we are able to get required rational numbers in step 2 itself. Else we would have taken its factors, that is, now we would have taken with 12. If not with 12, then 18 and so on. So that is your fourth part of your question number first. Question second. Write 4 more rational numbers in each of the following patterns. So we have to find 4 more rational numbers by first recognizing the patterns. First part, minus 3 over 5, comma, minus 6 over 10 and so on. So first of all, we will write the given rational numbers. So minus 3 over 5, this and this one. Now we have to find the pattern. Now remember, in this thing, while finding the pattern, as you have also learned in this chapter, you're not going to find it with the help of addition or subtraction. You have to find either with multiplication or with division, because equivalent fractions can be deduced by either multiplying or dividing, not by addition or subtractions. So do not go for that. For example, if you're considering this question, now if you try to find 5 plus 5 is 10, 10 plus 5 is 15, plus 5 is 20. Now you may say that plus 5 is 25 and plus 5 will be 30. Well, this may give you right answer, but it will not give you all the time. So don't do this mistake ever. You have to only find the pattern with the help of multiplication or with division. Likewise, you cannot do here as well. That is plus 3, plus 3, plus 3. Although they appear to be correct, but you have to find with the help of multiplication and division. Remember this. So first of all, you are going to write this. How we can get this? We are writing the same thing, multiply with 1. So if you are multiplying with 1, you have to do it in both numerator and denominator. Then only your fraction remains equivalent, otherwise it changes. For an instance, if you are multiplying here at numerator with 1 and here with some other number, then the rational number is no more equivalent. So remember this also. So when you multiply it with 1 on both numerator and denominator, you get the same thing. Now 3 into 2 is 6 and 5 into 2 is 10. So from here we get an idea. So minus 6 over 10 can be written as this rational number multiply with 2. Again, on both numerator and denominator, the same value. So minus 6 and 10. Now again, how we can deduce this? Minus 9 over 15. Well, we have to find this in terms of this only. 1, 2 and 3. Now we have got the pattern. It is sufficient to find the pattern with 3 consecutive numbers. Now 3 on both sides, that is numerator and denominator, minus 9 and 5 3s are 15. Again with 4, 3 4s are 12, minus is also there, 5 4s are 20. So we are getting correct values. That is, we have found the pattern. But remember, you have to multiply both numerator and denominator by these numbers. So this is your base value, that is minus 3 over 5. We are going to multiply it with 5 in both numerator and denominator. So 5 into minus 3 is minus 15, 5 5 is 25. So this is one rational number. Another is by multiplying with 6 on both sides, that is numerator and denominator. 6 3s are 18 with minus sign, 6 5s are 30. Now with 7, 7 3s are 21, plus minus minus, 7 5s are 35. The last one by 8. 8 3s are 24, and there is minus sign, so minus 8 5s are 40. So these are 4 required rational numbers. Similarly, we will do for the rest of the parts. Second part, minus 1 over 4, comma minus 2 over 8, comma minus 3 over 12, and we have to find 4 more rational numbers. So first of all, as we did in previous part, we will write the numbers or the rational numbers we have written here. Now we try to find the pattern. So first of all, we'll take the base value. This is your base value or the initial. Here this is base value, here it is base value, here it is base value or base rational number. Then what should be written in this base value to get this? Obviously by multiplying it with 1 on both numerator and denominator. Now here, how we can get minus 2 over 8 with the help of this base value? Clearly by multiplying it with 2. So we get this thing. Now again, how we can achieve this from this base value? By multiplying it with 3. So you got an idea. We are multiplying the base value with 1, 2, 3. And for the next 4 numbers, we should multiply it with 4, 5, 6, 7. So we are taking the base value and we are multiplying it with 4, 5, 6, 7. So you got the idea. And minus 4 into 1 is minus 4. 4 into 4 is 16. 5 into minus 1 is minus 5. 5 4s are 20. 6 into minus 1 is minus 6. 6 4s are 24. 7 into minus 1 is minus 7. 7 4s are 28. So these are your next 4 rational numbers. And in these, you don't have to get them to simplest form because you are just simply asked to find more rational numbers. So that's your second. Now, third, we will do similarly. First of all, we are writing these given rational numbers, minus 1 over 6, 2 over minus 12, and so on. We are writing the base value. What should be multiplied to it to get this thing? By 1. So we have multiplied it with 1. Now in this question, here is bit difference because minus sign is getting down. And we have also told you in the previous part, and you have also learned in this chapter, that minus sign can float to either numerator or denominator, or it can be written before the fraction. These are all same. So we have also shifted in the base value towards denominator. Now what should be multiplied to get this thing? By 2. By 2. So 2 into 2 and minus 6 into 2 is minus 12. Similarly, we'll do for these. Shifting negative towards denominator because this thing is equal to this thing. Now 3 into minus 18 here. 4 into 6 4 is 24, minus 24. So now we have again recognized the pattern. It is getting multiplied with 1, 2, 3, 4. And for next 4, the base value must be multiplied with 5, 6, 7, 8. So we are doing the same. This has been left for you and you got the idea. So that is your third. Likewise, we'll do for the fourth part. Fourth part, minus 2 over 3, 2 over minus 3, 4 over minus 6, 6 over minus 9. If you observe here, now you can see in the second rational number. The same number has been written, only difference is that minus sign has been shifted towards denominator from numerator. So first of all, we will write the given rational numbers minus 2 over 3, this, and this. Now we will try to find the pattern. So in first one, it is very easy. If you multiply it with 1 on both numerator and denominator, you will get the same number. Here, values are not changed, only the sign has been changed. So here we can shift the base value negative sign towards denominator and multiplying it with 1 only. So we get 2 over minus 3. But now here is a change. 2 into 2 gives you 4, minus 3 into 2 gives you minus 6. So you have to check it in fourth rational number as well, whether the pattern is changing or not. So when you observe that, when you multiply 2 with 3, you get 6, and minus 3 with 3, you get minus 9. So clearly now we are getting the pattern. In first, only sign is changing. So 1, 1, 2, 3. So next should be 4, 5, 6, 7. So we will do the same. We will take the base value of which we have shifted the negative sign towards denominator. So we are writing the same thing here. We got to multiply it with 4, 5, 6, and 7, and rest of the procedure is same. So you get 4 to the 8, 4 3s are 12 with minus sign, 5 to the 10, 5 into minus 3 is 15, that is minus 15, and 6 into 2 is 12, 6 into minus 3 is minus 18, 7 to the 14, 7 into minus 3 is minus 21. So these are the required 4 more rational numbers for fourth part. So that is your second question. Question third. Give 4 rational numbers equivalent to. First, minus 2 over 7. So first of all, you write the base value. Now this is the only value here, the rational number minus 2 over 7. We have to find 4 equivalent to these rational numbers. So what are equivalent first of all? As we have discussed in previous parts, by equivalent we mean that we are going to multiply it with same number in numerator or denominator. You can also divide it with same number in numerator and denominator. The only thing is that you cannot add or subtract in order to achieve equivalent. This is just a concept of ratio. The ratio has to be maintained. The only difference between ratio and rational number is that rational number consists of integers, whereas ratio doesn't have that. Whereas ratio consists of natural numbers. So now we are going to multiply it with 2 in order to get first rational number. It's simple. We have to do it on both numerator and denominator. 2 into minus 2 is minus 4. 7 into 2 is 14. Now multiplying it with 3 on both numerator and denominator, then with 4, and then with 5. If we were asked to find 5, then we would have multiplied it with 6 in both numerator and denominator. Rest is very easy. 3 to the 6 with minus sign, 7 to the 21, 4 into minus 2 is minus 8, 7 4 is 28, and likewise this. Similarly for second, 5 into minus 3, multiply it with 2 on both sides, you get 5 to the 10, and 3 into 2, minus 6, because here it is minus. 5 to the 15, minus 3 into 3 is minus 9, and with the same method, you can do rest of them. Same thing here, 4 over 9 into 2 over 2, that is 4 to the 8, 9 to the 18. You can also take it as 4 into 8, then you have to take 9 into 8. So 4 into 3 is 12, 9 3 is 27. Likewise, and here 4 5 is 20, 9 5 is 45. So this was very easy question. The only thing is that you have to take those numbers which you find very easy to multiply. You can also divide it rather than multiplying. So that is your question number third. Question fourth. Draw the number line and represent the following rational numbers on it. Before solving such type of questions, you have to keep in mind that whether you have a proper fraction or improper fraction. So what are those? A proper is this one, where numerator is smaller than denominator, whereas improper is this one. Just ignore the signs for the moment. Here numerator is greater than denominator, so therefore it is improper. And the other way of seeing these rational numbers or fractions is this. 3 over 4 means 3 out of 4. That is, if we have total 4 parts, we are selecting 3 out of them. Again, 5 parts out of 8. Now here 7 parts out of 4. Well, it doesn't seem correct, but if you look at it in other way, 4 are complete and 3 are extra. That is 7. So we are taking 7 parts where each part is having 4 measures. Again here 7 out of 8. So with this idea, we will try to represent them on the number line. So this is your number line, and you have to take, and since when you try to solve it, its value is less than 1. 3 by 4 is less than 1 and greater than 0. Therefore the point must lie between 0 and 1. That's how you select your extreme points. Now we have to divide this number line that we have selected of interval 0 and 1. These are intervals in 4 parts, because denominator represents the number of parts. We are going to divide that number line. So 4 means equal parts. Therefore 1, 2, 3 and 4, and we are asked to select 3. That is, we have to represent 3 by 4. So this will be 0. This is your 1 by 4, 2 by 4, 3 by 4. So this is the point that we are required to represent. That's your first. In the same way, we will do second. Sign only means direction. If this was positive, then we would have taken it towards right hand side of 0. So remember, sign just means position. Rest the method is same. Now we have to divide 8. And again, minus 5 by 8 is less than minus 1 and it is greater than 0. Therefore, we selected two extreme points, that is minus 1 and 0. Now we have to divide this whole scale into 8 equal parts. So we have divided it 1, 2, 3, 4, 5, 6, 7, 8. Now we are required to minus 5. So if 0 is here, then minus 1 will be here, and minus 2 over 8 will be here, so on, and we reach to point minus 5 over 8. So that's your minus 5 by 8 on the number line. Now here's the tricky question. Minus 7 over 4. From this rational number, what we know so far, that we have to divide the scale into 4 equal parts. But since it is improper, that means 4 are already there, 3 are extra. Therefore, when you try to solve, it lies between minus 1 and minus 2. Because 4 is complete. Hence, when you construct a scale, you get two extreme positions. Either you can take minus 2 to 0, or you can also take minus 2 to minus 1. So if 0 is here, we are dividing the scale in 4 equal parts. This is 1, 2, 3, 4. But since this is exceeding than 4 parts, so here it would be minus 4 over 4. But we don't have to locate this point. We have to locate minus 7. So you can see it as follows. 7 parts. 1, 2, 3, 4, 5, 6, 7. And also when you try to solve it, it is minus 1 and 3 by 4. That is 1 is complete. That is 4 parts plus 3 are extra. This is also a mixed fraction. And when you solve it, it is minus 4 and minus 3 is minus 7 over 4. That's a third. Now again, 7 over 8, it is a proper fraction because numerator is smaller than denominator. And when you try to solve it, the value lies between 0 and 1. And you have to divide the scale, that is 0 to 1, in 8 equal parts. So 1, 2, 3, 4, 5, 6, 7 and 8. And you have to locate 7th part out of 8. So 0, 1, 2, 3, so on up to 7 over 8. This is the way to represent rational number on a number line. Just be aware of this whenever the rational number is improper fraction. And also, one thing you studied in this chapter, these are positive rational numbers, these are negative rational numbers. However, this is improper negative rational number because numerator is greater as compared to denominator. While comparing, do not take into consideration the signs. These are just for directions. That's your question number 4. Question number 5. The points P, Q, R, S, T, U, A and B on the number line are such that, so these are the points, they are equal, and TR equals RS and that equals SU, and AP equals PQ and equals QV. Name the rational numbers represented by PQRS. That is, you have to find the measure. According to the question, you have these all points equal. If you visualize it, that every integer is divided into equal 3 parts, that is 1, 2, 3, and also 1, 2, 3, and these are equal and these are equal as well. This means that the interval between two numbers on a number line are equal. Therefore, by using that, we have to find the rational numbers represented by PQRS, that is their measures, and this line is given to us. Here is your center point, that is 0. This is your left side, that is negative integers. This is your positive, that is positive integers. And rational numbers are subset of integers. Now, since we know that each interval is divided into 3 equal parts, this means in denominator we will have 3, as we have studied in our previous questions as well. So this part be your 1 by 3, this will be 2 by 3, this will be 3 by 3. And this is 1 complete. Therefore, it will be 1 and 1 by 3. This will be 1 and 2 by 3. And this will be 1 and 3 by 3. This means 1 plus 1 is 2. Similarly, on the right hand side, in the positive side, 2 complete, that is 2 is a whole number. This is 1 by 3, 2 by 3 and 3 by 3. Therefore, 2 and 1 by 3, 2 and 2 by 3. Therefore, 2 and 1 by 3, 2 and 2 by 3. This is complete 3, that is whole number. So you can deduce them likewise. Similarly, you can divide these two extremes in 3 equal parts, that is 1, 2, 3. But since we are only asked to find P, Q, R, S, so here they are in the boxes. P is 2 and 1 by 3, Q is 2 and 2 by 3, R is 1 and 1 by 3, and S is 1 and 2 by 3. In other way, you can understand it as, if you have a car, you have to travel from T to U. Then you have 3 equal partitions, that is 3 equal distances. Suppose this is 5 km, this is 5 km, this is 5 km. In total 15 km. But it is on negative side. Same thing is here, 5 km, 5 km, 5 km. So this car travels a distance of 1 by 3 from A to P, then another 1 by 3 from P to Q, and the last 1 by 3 from Q to P. However, it has already completed this portion. Therefore, we have to add 2 and 1 by 3, 2 and 2 by 3, 2 and 3 by 3, which is equal to 3 itself, because 2 plus 1. Same happens on negative side. So this is how you do your question number 5th. Question number 6. Which of the following pairs represent the same rational numbers? In these questions, by same rational number, we means they must be equivalent. And how we can deduce equivalent rational numbers or equivalent ratios? By first of all converting them to lowest form. So we will try to find the lowest term of those rational numbers whose lowest term is achievable. So let's go for the first. Minus 7 by 21 and 3 by 9. Obviously, they are reducible to lowest form. Here we have done that. So common factor is 7. So 7 into minus 1 will give you minus 7. And 3 into 7 will give you 21. Not further reducible. And then doing for this thing. 3 is a common factor or the common HCF. If you say more technically in mathematical language, that 1 3 is a 3, 3 3 is a 9. Clearly, even the numbers are equal, but the signs are different, so they are not equal. Therefore, what we did, we first write equal sign and we then cross it. It means they are not equal to each other. That is your first. Moving on to second. Minus 16 over 20 and 20 over 25. First of all, ignore these negative signs. This negative can be brought here and there is no change in the value of this rational number. The same is the case with this. Just ignore negative signs. First, just try to reduce them. So we are doing the same here. 5 4s are 20, minus 4 4s are minus 16. And here, 4 5s are 20 and minus 5 5s are minus 25. Again, you get the same numbers. The only difference is that sign is here in numerator, here it is in denominator. But this doesn't matter, as we have also told in previous parts that this sign can float either to denominator or to numerator, or it can be written here before this rational number itself. These are equal and we have written equal sign. Third, minus 2 over 3 and 2 by 3. Well, these are not reducible, and minus minus is plus. Well, remember these things here. Here, what we are doing, it is of division. So we'll go to this rule. That is minus divided by minus gives you positive. And another trick to remember these is this. If you have both same sign, whether positive or negative, they must be both. In case of multiplication or in division, your answer is going to be positive only. And if they are different signs, in case of multiplication or division, likewise, like here we have plus minus, minus plus, plus minus, minus plus. That's always leading you to negative sign. So minus minus gets cancelled out. You can also do like this, and 2 by 3 is equal to 2 by 3 indeed. So this is your correct. Now here, well, this is not further reducible and this is reducible. So first of all, reduce like this. With 2 is common with this. Either you can reduce directly with the HCF of the number of the 12 and 20, or you can go in parts. So prefer to go in parts when you are learning first. So 2 6 is 12, minus sign is there, therefore we wrote minus sign, and 2 1s are 2, 0 as it is. Now further reducible with 2 as common. So 3 2s are 6 and 5 2s are 10 and minus sign as it is. So we got minus 3 over 5, which indeed is equal. Therefore we are writing equal sign. Fifth, again this minus can float to this side. Now not further reducible, this is reducible with a common factor as 3. So minus 8 3s are minus 24, or the other way is 8 3s are 24, just write minus sign afterwards. 5 3s are 15 and you get minus 8 over 5. As we say, this minus sign from denominator can be floated to this. Henceforth, they are equal. That is your fifth. Sixth, these are not further reducible and therefore not equal as well. Now here, minus minus is plus. Again, by the same concept, both signs, whether division or multiplication, will always give you positive sign. But here, even the numbers are same, even the fraction is same, but there is negative sign, so they are not equal. That is your last. So in this way, you do such type of questions. Question 7. Rewrite the following rational numbers in the simplest form. That is, we have to reduce them. By simplest form, we mean that we have to reduce the given rational number. So here it is a negative rational number because negative sign is there. So we will try to simplify it. So it is reducible, yes, with the factor of 2. So 4 2s are 8, 3 2s are 6, and fixed minus sign because we have minus sign here. That is your first. Second, yes, 5 is common factor. You can very well see whenever in the units place or in the ones place you have 5 or 0, it is always divisible with 5. This you have learnt in your previous classes as well. That is divisibility rule. So keep that in mind. 5 5s are 25, 9 5s are 45, not further reducible. Here. Now with the factor 2, because one's digit is a multiple of 2. So 22 2s are 44, 36 2s are 72. Other way is to do like this. 2 3s are 6, 1 2. That is remainder, 1 is remainder, 1 2 2 6 are 12. Now further with 2, 11 2s are 22, and 2 1s are 2, 1 is remainder, 16, 2 8s are 16. And just fixing negative signs, not further reducible. Now the last part, again 2 is common factor, 5 2s are 10, 4 2s are 8, fixing minus sign, minus 4 over 5. So these are simplest form of these rational numbers. So that is the concept behind it. That is your 7th. Question number 8. Fill in the boxes with the correct symbol of greater than, less than, and equal. Number first, minus 5 over 7, it is smaller than 2 by 3. How we came to this conclusion directly? Well, this is a negative number and this is a positive number. We don't have to go any further because, negative numbers are smaller than greater number. Therefore, this rational number is smaller than this rational number. And the trick to remember this sign is that wherever it is greater number, you just open these braces, and wherever it is smaller number, you just make an angle towards that side. That is the trick to remember for the long run. Now second, now here we cannot apply that trick, first of all. Why? Because both are negative numbers and both denominators are not same. So you have to take your LCM, because you have learned in your previous classes you can only compare if the denominators are equal. So first of all, we try to do that with the help of the LCM. Clearly 5 7s are 35. We took 35 on both denominators. 5, how much is 35? 5 7s are 35, and this 7 factor is getting multiplied with numerator. 7 4s are 28. Obviously negative sign is there. Same thing here. 7 5s are 35, 5 5s are 25 with negative sign. Now you can clearly visualize. Minus 28 is smaller as compared to minus 25. Don't go with the numbers. It is on negative side of the number line. The another trick is to do this. First, ignore the signs. Just see which is greater. 28 is greater if you remove the sign. Then just flip things. The number which is greater will be your smaller. Therefore, you write this thing, smaller than. And again, greater towards greater number. This is greater as compared to this. That's a second. Third, again, you cannot use that trick or the shortcut formula because both are negative. This negative can flow to any side. Now, but you can see this 16. If we try to simplify this rational number, you get an 8 and then you can compare it. So we'll try to solve this, and this is not further reducible. So 8 2s are 16, minus sign fixed, 7 2s are 14. Well, you are getting the same thing. Negative sign doesn't matter. So 7 over 8 equals minus 7 over 8. Therefore, they are equal. Fourth, again, both negative, cannot use that trick, and both denominators are not same. Therefore, you are going for LCM. So these are the steps. LCM is 20, 5 4s are 20. Writing 20 on both denominators. Now 5 4s are 20, 8 4s are 32, negative sign fixed. Now here 4 5s are 20, 5 7s are 35, negative sign fixed. Clearly 32 is greater, therefore you are opening these brackets towards greater number. That's your fourth. Fifth, now here negative sign, different denominators, going for LCM. 3 4s are 12, LCM. 3 4s are 12, 4 1s are 4 with negative sign. This negative sign we have floated before solving towards numerator in our mind only. Then here 4 3s are 12, 3 into 1 is 3. Again this is greater, therefore opening towards greater number. And now moving to 6th, just doing it in mind, move it towards upwards because negative sign can be floated to any numerator or denominator if it is single. So they are equal. Here you don't have to do anything. It's just like first one, because 0 is in the center and negative is towards left hand side of a number line. Therefore 0 is greater than any of the negative number. That is your question number 8. Question number 9. Which is greater in each of the following? Again, you have to compare them. This is very similar to the previous question. First of all, same sign, different denominators, taking LCM. 6 is LCM, 3 2s are 6, 2 2s are 4, 2 3s are 6, 3 5s are 15, 15 is greater, therefore you can compare it very well, opening these braces towards greater number. Second, same sign, different denominators, you cannot directly compare them, taking LCM. 6 will be the LCM, then 6 1s are 6, 1 5s are 5 with negative sign, 3 2s are 6, 2 4s are 8 with negative sign. Therefore, negative 5 is greater because we are talking in terms of negative numbers. Third, same sign, just floating this negative towards numerator in mind. And 4 3s are 12, LCM, 4 3s are 12, 3 3s are 9 with negative sign. Now, this negative we have taken towards numerator in our mind. So 3 4s are 12, 4 2s are 8, negative sign. Negative 8 is greater as compared to negative 9. Now here, don't even have to compare. Negative numbers are smaller as compared to greater number. Now here, first, this is a mixed rational number. To be more precise, it is negative mixed rational number. So first try to solve it. 7 3s are 21, 21 plus 2 is 23, minus 23 over 7, 5 3s are 15, 15 plus 4 is 19, and fixing negative signs as well. Same sign, different denominators, LCM. 7 5s are 35, 5 23s are 115 with negative sign. Then 5 7s are 35, and 7 into 19 is 133. And how you can do it here itself, you're just remembering this. 7 9s are 63, 6 is carry, 7 into 1 is 7, plus 6 is 13. Likewise, you can also find this 115. So try to avoid rough space, do more calculations in mind only. So clearly, smaller number in negative is greater as compared to bigger number in negative, so opening towards greater number. That is your 5th of your question number 9th. Question 10th. Write the following rational numbers in ascending order. Before solving the question, let's revisit this term, that is ascending and descending. Ascending is getting up from the lowest number. First of all, you have 213, then 230, that is you are increasing your numbers. So these are ascending. Then you have descending. Descending is just opposite of ascending. So these are English language terms and also used in mathematics. Similarly, in English, you say the car is descending from the hill, because you see hill is at the top and it is coming downwards. So it is descending. It's an English term. Again, ascending, the value of money is ascending. You can use it in various forms. That is, the cost of dollar is increasing with respect to Indian currency. So first, for instance, it was 65 rupees and 66 point something. So the value is ascending from the previous one. So these are the English terms which you must keep in mind. By knowing that, let's visit further. So we have to write the following rational numbers in ascending order, that is from lowest to up. So let's see here. All are negative, their bases are same. So we need not to take any LCM, we can directly do it. And what happens in negative numbers? That smaller number will be greater. So this thing is here, because it is smaller, it will be the most greatest. Then the most smallest will be this one, because it is greater but in negative, therefore it is smallest. And here it is in middle. So these are already arranged in your ascending order. That's your first. Second, negative signs but different denominators. So we have to make first denominators same. So this is 9, and you know very well both are 3. They can be converted to 9 by multiplying by 3 on denominator. By doing so, you have to do it in numerator as well, so that the value of this fraction must remain equivalent. That's what we have studied in previous questions. So doing for this, minus 3 into 3 will be minus 3. Just do these things in mind. Then 3 into 3 is 9. You don't have to change this because it is already in 9. Then here, 4 3s are 12 and 3 3s are 9, and negative sign was also there. Now we can compare it very well. Now, as we have mentioned earlier, that the greater the number, it will be smaller in case of negative. So this thing is smaller than what is the greatest number? And if you take it in positive, this is 3, so it will be in middle. This is the smallest in positive, but since it is negative, it will be the greatest because it is closer to 0. So therefore this, however, you cannot write these things. You have to represent in terms of given question. So you are just picking it up. So we got this from this. This means this. So you're writing minus 4 by 3 first of all. Then you have this thing which you picked from here, just map it. So it is coming from -1/3. So this thing, and the only last one is this thing. You don't even have to map it. So that is your second, and you know how these signs are placed. Then third one, similar sign. You're gonna directly say anything. You have to make common basis, but it's not case like this. You have to take LCM. So the trick to do LCM is take the bigger number. 7 is bigger number. Take its multiple. 7 2s are 14. But 2 can give you 14. 4 cannot give you 14 because 4 3s are 12. 4 4s are 16. You don't get 14. Move to next with a greater number. So 7 3s are 21. Again, this cannot give you 21. This cannot give you 21. So 7 4s are 28. Next one. Well, this can give you 28. This can give you 28. This can give you 28. So LCM is 28. Decided. Now, just reading table. 7 4s are 28 and 4 is the multiple. Multiply that 4 with this number. So 4 3s are 12 and minus sign is also attached. Now here, 2 to 28. 2 into 14. So 14 3s are 42. Fixing negative sign. Again here. 4. How much is the 28? 7s are 7 3s are 21. Negative sign. Now you can compare it. Greater the number, smallest it will be. So first just arrange these like this, and then we have -21 and the smaller will be the greater. Now map it. This is coming from this, that means from this. -3/2 you will write here. This is coming from this and map it, -3/4. This way you don't get puzzled. And the last one is obviously, the only left one is -3/7. This is the first way of doing this type of a question. And in such type of a question where numerator is same, if you notice numerator is same, there is another trick. Or the method, take any number. It can be -1, it can be -250, or any number. You just treat it as a pizza. So you are making it 7 parts in first place, then 2 parts of the whole complete pizza, then 4 parts of complete whole pizza. So 7 parts will get you a smaller share. 2 means half, you are just dividing it half, you are getting bigger share. And 4 lies in between. So clearly you are getting bigger share in this, but it is negative. That means it will be your smallest part because we are talking in negative. Therefore this came here. In this part you will get the smallest. That is, if you are going to do 7 parts of that pizza, you're getting smallest portion like in this picture. But it is negative, so it will be the biggest one. Therefore it came here, and the center one as it is. So this is just a way if you're doing something in mind. With practice, you will get the idea. So there are many ways of doing same kind of a questions. With this, your exercise gets completed, and that is your last question, question 10th.